Okay, let's take a look at this third example here of the solving a polynomial inequality of higher degree. Here in example D, we've got a degree 4 quartic polynomial. Right, with that said, we can have up to 4 critical values, right, based off it being a degree 4 polynomial. We can have up to 4 zeros. With that said, let's see what we have. So we're going to solve this one, and let's go ahead and relabel this one, example C. So example C, again, I got x to the fourth less than 4x squared. Well, again, step one, let's solve the related equation. So let's drop the inequality symbol, and let's put in a equal sign. So as we do that, we got x to the fourth power equal to 4x squared. And as we're solving for x, we're going to go ahead and set everything on one side equal to 0. Let's go ahead and subtract the 4x squared over. And as we do that, we have our degree 4 polynomial of x to the fourth power minus 4x squared equal to 0. And again, with a degree 4, we can have 4 linear factors, right? Degree 4 polynomial has 4 linear factors. And with this one, we see again we can begin factoring with the GCF. So our greatest common factor in these two x terms, we can bring an x squared out of both. So let's go ahead and do that. Let's go ahead and factor out the GCF of x squared. As we do that, we'll be left with an x squared here in the first term. X squared times x squared is x to the fourth power. And we're left with a minus 4 in the second term. X squared times minus 4 is negative 4x squared. And as we break down these two quadratic factors into their two linear factors, we know x squared factors towards 2x times x. X squared minus 4 is a difference of squares. Right, we're squaring x and we're squaring 2, so that's x minus 2, x plus 2. So there are 4 linear factors for the degree 4 polynomial. So that implies we got x equal to 0, right? The first factor, which is repeated, has a multiplicity of 2. X minus 2 equal to 0, or x plus 2 equal to 0. So in the all, we have 3 zeros, right? One of our zeros is repeated, it's used 2 times, based off its factor x, right, being squared. So multiplicity on 0 is 2 as we review back to multiplicity. But those are our critical values. So again, that's our next step. So we've got our critical values. Now we're ready to set up that x line, and we can look at, right, where our solution set intervals are going to fall. So let's go ahead and build that. So as we build in the x line, here's all real numbers x, negative 2, 0, and 2. And with that said, this is a less than problem, not a less than equal to. So remember these zeros, these x-intercept locations of our graph, they're not going to be solutions because we don't want to equal, right? It's just less than. So not less than equal to. So less than equal to greater than equal to, right? We'll be including the zeros. They'll be solutions to the polynomial inequality. But with that said, we have some intervals that we can look at and set up and test. So what are our possible solution set intervals? So let's look at our test intervals. So all x values less than negative 2. All the x values less than negative 2 and less than 0. All the values between 0 and 2. And then, of course, 2 to infinity. So you can see, again, the 4 regions, right, that are formed. And then we're going to pick a test value. And we're going to find out which of these make up the solution set. So again, something easy to plug in. Let's go ahead and identify a test value from each region. So I'm going to look negative 3 for all the values less than negative 2. I'm going to use the integer of negative 1 to test negative 2 to 0. I'm going to use 1, a whole number, to test 0 to 2. And then I'm going to use 3 to test it 2 to infinity. So let's see which of these would work. Let's start with our first interval. So we plug it back in. So going to the original inequality, x to the fourth power, so negative 3 to the fourth power, is it less than 4 times x squared, 4 times negative 3 squared? Well, what is negative 3 to the fourth power? Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. Negative 27 times negative 3 is a positive 81. So we got 81 here. And here we got 4 times negative 3 squared, 4 times 9. So I got 36. Well, 81 is not less than 36. 81 is greater than 36. So negative 3 is not a solution to this degree 4 quartic inequality. So we want to make sure we exclude that interval from the solution set. Now let's test negative 2 to 0. So we're picking negative 1. So negative 1 to the 4th power is it less than 4 times negative 1 squared? Well, negative 1 to the 4th power is 1. 4 times negative 1 squared is 4 times 1, which is 4. And yes, 1 is less than 4. True. So this is part of the solution set. So all x values greater than negative 2 and less than 0 we need to include. How about 0 to 2? Let's test it. Plug in 1. So 1 to the 4th power is it less than 4 times 1 squared. 1 is less than 4. Again, same thing we just got in the previous test. So yes, it is part of the solution set. All the values greater than 0 and less than 2 need to be included. And then let's look at the last interval. So let's test it. So I want to test 2 to infinity. And we picked, right, in this interval, we picked a value of 3. So our test value is 3. Let's plug that in. So it's 3 to the 4th power less than 4 times 3 squared. Well, 3 to the 4th power is 81. 4 times 3 squared, 4 times 9 are 36. And that's not true. 81 is greater than 36. Not in the solution set. So our solution set is made up of 2 intervals. So we had 4 intervals to test. 2 of them hold true. We got all the x values greater than negative 2 and less than 0. Or all the values greater than 0 and less than 2. There's our solution set to the quartic inequality. And again, this will be a good one. Let's go look at it. We looked at the last one graphically. Let's go ahead and do this one graphically. Let's go ahead and take a quick look at it and see these solutions. Let's pull up our grapher. So in the y equal button, let's type it in x raised to the 4th power minus 4x squared. As we graph that on a standard window, you can see here now, when are we less than 0? That was our question. So we had a less than problem. Well, here's our critical value, right here at negative 2, right, which again was one of our zeros, our solutions. Well, negative 2 all the way over till we get back to the origin. Between negative 2 and 0, now we don't want to include negative 2 or 0 because it equals 0 there. This one is less than, right? Those are in the solution set, which we included. And you can see 0 to 2, got that same negative outputs. Those are less than 0. We just kind of make sure we don't include, right, the critical value of 2. So again, that's not in the solution set. But you can see how at 0 it bounces off and forms a turning point. If you remember, we had an even multiplicity. Multiplicity was 2. You remember that forms a turning point at that location. And it crosses through at negative 2 and 2 based off the odd multiplicities of 1. They're factors we only use one time. So those are characteristics that we talked about with polynomials. All right, even multiplicity, its tangent bounces off, forms a turning point. Odd, it crosses through the x-intercept at 0. But again, it's always nice to see it visually with our grapher.